What I'm holding right here is called a silicon carbide wafer. It is 150 millimeters or 6-inch, and it's worth somewhere between a few hundred US dollars to a few thousand US dollars. This 6-inch silicon carbide wafer is a revolutionary material. It's basically transforming the automotive industry today. And here's the interesting part. Every single EVs out there uses between 1 and 4 of these wafers. So you can imagine, with millions of EVs that are being produced every single year, we're talking about billion-dollar industry built on this remarkable material. So let's just make an example and see how many EVs were sold last year globally. So global EV sales 2024. So according to Google, 17 million units were sold. Now you can imagine how many EVs will be sold in the next 5 years, and imagine how many wafers that is needed in order to satisfy this demand. So why is it that silicon carbide is so popular in the EV industry? The silicon carbide revolution began around when Tesla announced that they were going to use silicon carbide in their Model 3. I think that was around 17-18. This wasn't just another component upgrade. It was a declaration that it would reshape the entire industry. Since that pivotal moment, massive investment, billions and billions of dollars have poured into silicon carbide development and production scaling. So for the past 10 years, we have witnessed an incredible evolution from 4-inch to 6-inch and now to 8-inch silicon carbide wafer sizes. Today 6-inch is the standard, but 8-inch is now maturing for mass production. And I believe that 8-inch will soon be the golden standard. So talking about the size, why the size matters. It's all about economics and efficiency. When you move from 4-inch to 6-inch and now to 8-inch, you can manufacture significantly more chips on a single wafer. More chips per wafer means lower cost, and this is crucial when we are talking about volumes needed for mass EV production. But here's what makes the silicon carbide industry so exclusive. Only a handful of silicon carbide companies are able to deliver high quality silicon carbide sustainably and reliably. The barriers to entry are enormous, which is exactly why this remains such a lucrative, concentrated market. And always remember, not every wafer makes it into the market. Only less than 40% of the silicon carbide produced can satisfy the EV demand. Only the highest quality wafers are suitable for EVs, meaning substantial quantities don't meet the grade, further driving up the cost and scarcity. So generally speaking, wafers can be divided into 3 different kinds of grades. D grade for dummy grade, R grade for research grade, and P grade for production grade. And of course, dummy grade for the lowest quality, whereas P grade has the highest quality. So why is it that silicon carbide is so popular compared to traditional silicon? What makes the silicon carbide so special? So there's 3 game-changing advantages. First, the incredible hardness. Silicon carbide is one of the hardest material known, making it extremely durable and reliable in a demanding automotive environment. Second, temperature resilience. Compared to silicon carbide could sustain much higher temperature. This means it can maintain high performance under extreme heat conditions. And this is crucial for EV powertrains that generates lots and lots of thermal stress. And the third, superior efficiency. And this is a significant one. Silicon carbide devices can handle much higher voltages and frequencies while losing less energy. And what does that mean in electric vehicles? Well, that basically directly translates into longer range, faster charging, and better overall performance. So at the end of the day, think about it. Silicon carbide wafers basically cuts the global energy waste. It makes EVs affordable, and that is exactly why silicon carbide wafers is a billion-dollar business.